Hello and welcome back to another Island 54 development stream where I'm working on my survival crafting MMO built in Unity 3D and TypeScript. Today I am starting on what I was hoping to get started on, I think it was end of last week, which is the pub sub mechanism for my services. And I obviously got quite distracted by the fact that there was an issue with my UDP traffic, which has now been corrected. Now, PubSub is a fairly straightforward concept. It basically is this idea that one service can publish a message or an event, and some other service is able to pick up that message or event. There are lots of different models for how that can work, which can make it a bit more complicated. For example, perhaps an event needs to go out into some ticker service for maybe AI processing, but maybe you've also got a logging service that you also want to receive that message. Uh, in our case, we really just want to process each message approximately once. Now, there is I think it's a law in computer science uh, that you can you can never trivially cause something to happen exactly once. So it's not possible for this service to send a message and have it processed by exactly one of these instances. The two guarantees you can make are either it will be processed at most once. So maybe it'll be processed by this one, maybe it'll be processed by this one, maybe it'll be processed by neither. The other guarantee you can make instead is that it will be processed at least once. And so in that situation, it effectively persists over in here. And then one of these will come through and pull it off the message queue. There's no guarantee, though, that another one won't get its timing wrong or you won't get some weird reboot somewhere causing this second ticker service to also pick up that job. It turns out this is a much easier version of things to work on if you do expect things to be processed exactly once. And the way you do that is you make the operation that each of these is performing what we call idempotent. So that basically means it's a function that no matter how many times you execute it, it always does the same thing. So a really silly example of that is if you've got a function that returns f of x comma y, and maybe it's just going to return x plus y. This is a really simple idempotent function. If you've got another function, f of g, g of x, sorry, that returns, maybe it's going to do fetch y. It's going to fetch y from somewhere else. Maybe it's going to increment y. And then it's going to store y. And then return x plus y. This is not idempotent. I'm sure I could come up with a simpler example than this. And the reason it's not idempotent is just say over in here, we've got y starts out as 0. If we now call g of 10, this is going to return, well, it's going to fetch y, that's 0. It's going to increment it, that's 1. It's going to store it as 1. And then it's going to return the value 11. Next time we call it g of 10, it's going to fetch y. Well, y just got incremented, so that's now going to be 1. It becomes 2. And now when we return x plus y, the next time we call this function, it's going to be 12. Whereas obviously f of 10 comma 5 is always going to return 15 in this top case. Now, the problem is if you have a message delivered multiple times and what you're doing with that message is of this form, then you're going to end up effectively executing it twice. Whereas if it's of this form, it doesn't matter if you execute it twice, you're still just going to write out the original result. Now, a more practical example of that is I might have a function, maybe I want to go and increment stamina. Maybe that's my, and we want to increment it by 1. Now, my implementation for this, it would be really bad to do, player.stamina equal to, well, plus equals 1. Oops. This would be a really bad implementation because if the message got processed twice, then we'd increase their stamina twice. A much better implementation, and there's just no way of implementing this in an idempotent way. It's intrinsically using uh, the stamina, which can change under the hood. A better implementation might be stamina. We might pass through previous and increment. So in that case, we might pass through, hey, we're going to send a message. We want to increase their stamina from 53 and we want to increment it by 2. Now the implementation can say if player.stamina is equal to previous, then player.stamina plus equals increment. This is an example of an idempotent message. So anytime I send these messages, this is what I'm going to be doing. I'm going to be using this concept of storing what it used to be. And if we can't, if the stamina changes, then we know that someone else has gotten to this or something's changed. We can mark the message as unprocessed, and we just need to handle these failure conditions separately. This is by far the easiest way of doing it. Now, I have no idea which PubSub library I'm going to use. I basically need some sort of a library that I can push messages into and my services can take them out. In all of these cases, it is the session service that, well, this is a really bad example this is from my screenshot for this stream, by the way. This should actually be the entity service. But we're also going to have the session service talking out to the transmitter service. But in this case, what it will be publishing is it'll be publishing the sessions that need to be serviced that need to be contacted in this game tick. And this is how I can have multiple transmitters sharing the work between themselves. So if you imagine every tick, 1,000 sessions get pushed out into the queue. That'll be a slightly silly way of doing it, but let's just say 1,000 services get pushed out into the queue. These guys just keep on pulling sessions out of the queue and generating packets for them and sending them out to the sessions, to the session proxy. In the case that you've got, let's just go crazy, and I see in this game is massively popular and we've got 1 million users connected, this all of a sudden is a bit of a pain because we need something to be able to push these 1 million services in here, and we're going to end up with 1 million sessions getting passed out to these. So I'm going to use a slight optimization here right from the start, which is just to send the sessions through in bundles. The bundle size will be configurable, and we might just bundle up 10 sessions, might just all go out, and they'll get picked up by this guy, or 10 sessions will go out and get picked up by this guy. And because it's tunable, yeah, I can test it by saying do individual sessions. All right. So I need to choose a PubSub library. Now I have in mind what I'm likely to use. I suspect I'm going to use Redis. At the moment, we're already using it for our shared memory stores. You can see I've done a little bit of investigation around it already. I happen to know that one of the benefits of Redis's PubSub is that it is extremely fast. I believe that the latency is less than a millisecond, I believe, which is pretty good. My biggest question is what model it uses for subscribing. I need to make sure that messages are delivered approximately once. Obviously, it needs to be at least once. That's the whole point of these systems, is to go at least once. But I don't want every single message to go out to every single subscriber. So I'll just do a very simple proof of concept. I could read through this through this documentation to find the actual delivery mechanism. Although maybe I should look at distributed event because perhaps that's kind of what I want. Pub/sub messaging can be extended to create interesting distributed events. Let's say we have a structure that's stored in a hash. We want to update a client. That's the kind of thing that would be useful. The reason I'm interested in this line here, pub/sub gives no guarantees. I would assume it guarantees at least once delivery. But not without persistence enabled. Yeah, I believe that you have to do something to enable persistence, and then you do get, as depending on how you publish, you do get the guarantee at that point. Yeah, that's a fair point, not Matt W. But once you got persistence, you do get at least once delivery. Let's say I have a structure that's stored in a hash. Now, this is a really good case because in the case of the session service, these are stored. This is storing all of its sessions in a hash. So this is a case where we actually want to populate our message queue from a hash. So this may well be the kind of thing that we're after. So a pattern of channels. Only then fetch the hash at status. Although back to the at least once guarantee, the main thing I want is I don't want an at most once guarantee. Because an at most once guarantee absolutely implies a higher likelihood to drop messages, which is bad. That said, in this system, does it really matter? And maybe this is something that I should consider at this point, because if a session doesn't get serviced in a particular tick, it doesn't matter. Like, I really don't care because it will get serviced in the next tick. Pub/sub, yeah, so publishing and subscribing events. So a message queue. I'm about to integrate a message queue in between some of my services. Likewise for the entity service, if what these tickers do is they are basically querying the entity store repeatedly for entities that have specific components on them. Again, if something doesn't get processed in a given tick, I just don't care. Yeah, okay. Yeah, I'm not 100% sure either, Matt W. No, nothing to do with Subway. um, it doesn't have partitioning. Yeah, okay. So I'm actually quite a fan on that topic, Matt W, of not having. So just say this is Redis in here. Uh, if that's Redis in there, well, it is what it is. If that's Redis in there, I'm not much of a fan of the idea of the entity service publishing and the dependent services pulling messages out. One of the reasons is, yeah, if I use Redis and I outgrow Redis and need to replace this with something else, there's a fair bit of code that needs to get updated. A better approach in my mind, and this is kind of inspired by Netflix's way of doing things. I believe this one comes from Netflix. My experience with this particular architecture comes from Atlassian, who got most of their architecture from Netflix. In here, you might have a publisher service. You have some sort of a queue up here, and then you have your subscriber down here. And now what you can do is when you want to publish, you publish like that. But when you want to, when you're sending a message to a subscriber, you do it like, oh, what's that doing? Do it like this. So the subscriber makes blocking call into the publisher, who then goes and fetches the next message on your behalf. Um, so this means that if you do change your queuing implementation, you only need to change the publisher of the messages, because the publisher is responsible for interpreting the messages coming back out of the queue. It adds a tiny bit of latency, but it's just a cleaner, it gives you a much cleaner separation down in here. Means these services aren't as tightly coupled to each other. So this is likely what I'll be going for. Um, it's really easy to implement. You just need to put an endpoint on here that this one can call into, and you just need to make sure it's blocking. Okay. Pretty sure that's what you designed for your last work. Yeah, this is, I'm a massive, massive, massive fan of this architecture rather than the simplified view of it. Okay, so where am I at? So I'm going to try it with Redis and just see where I end up. So I am going to have to understand this stuff. So you guys are probably going to have to bear with me slightly a little bit through this as I read things. So I'm going to start just with a simple, well, I'll start probably looking at event queue. Uh, it sounds right, .NET-W. But yeah, as I just pointed out, I actually don't really want at least like looking at my use case, I don't want at least once delivery. I want at most once anyway. So, well, I don't need a delivery guarantee is more my point. So if you have at if you have at least once delivery, you must ensure that all of your messages are idempotent, like this kind of thing. So you can't have an increment operation. You can only have, I mean, let's be real. You wouldn't actually implement this increment. You'd implement a set stamina. Um, uh, a dropped message is not horrible in this case, and the reason is because this stuff is repeating on every tick. Likewise, in the entity service, as long as you know when you last processed a message, you can make up for it. So in the case of transmitting packets to the client, all it means is that you'll drop a packet out to the client, but you'll make up for it on the next one because of the way my transmitters work. They keep a copy of what they believe the client state to be. If they don't receive an event on one tick, then they will not update their state. And so when they get a tick for that session on the next tick, they'll just send out a slightly bigger packet. So a dropped message is absolutely fine in this case. In this case here, it's which is I like to think of this as the AI case, but it's also things like crafting and moving players and things like that. Um, it's a little bit more subtle in this case. But again, if we don't process an AI, for example, on a given tick, then next time we process that entity, it will, as long as we know how much time we're processing for, it will come back into sync. Now, I don't support that at the moment. And so at the moment, you actually see if I turn the tick rate up too high, the AI actually starts writing over itself. And the trolls start stepping backwards and forwards, slowly making their way to the right spot. But if I store, when I process AI for a tick, if I store that tick time uh, back on the entity, then next time a tick comes through, we can know whether or not we're processing. You know, if something gets written out back in time, the next time a tick comes through, it will look like we missed a tick, and it can then process for 2 ticks worth and just move the troll twice as far, for example. So it's quite straightforward to make these. And in fact, you need to make these resilient to dropped ticks. Um, uh, Also, got your game playing again. Well done. Until you try to move. Yeah, so I'm not concerned about dropped messages here. Now, if Redis were to provide at most once delivery, then what I could do is I could support um, non-idempotent functions, uh, but that's bad for other reasons. So if I instead support only idempotent messaging, and I implement things in a way that they will make up for it once they um, it'll make up for it once they get the next message, then I don't need any guarantees. No, it's actually also fine for crafting and damage and things because I'm implementing those as components. So they get persisted before they get executed. So I end up guaranteeing at least once execution in that case. So crafting, the client actually puts a component on the player entity. Um, uh, Damage gets applied in the ticker service itself by the AI at the moment. Worried about the publishing service being a single point of failure? No, because there will be multiple. While I'll ideally only write one implementation of this, it'll be a separate instance sitting between the entity service and the ticker service, or a separate cluster, and then a separate cluster sitting between the session service and the transmitters. If it goes down, then you'll lose this connection for a little while as it tries to come good again. But that's the same as if this service were to go down or this service were to go down. But it will come good again and it won't affect other parts of the system from executing. I'm cautiously convinced. No chance of breaking it on code update. Well, yeah, like if you push out a new fix. So I might as well go off on a tiny bit of a tangent here, which is around cloud deployment. Um, uh, so there's this concept of uh, I can't remember the colors that they use. Blue-green deploys. So let's just say you've got a single service. It's like a web app backend or something like that. That's not a microservice. It's just a monolithic service, but you might have multiple instances of them. Um, let's say we're going to have two just for redundancy. Um, there's your web app, and we've got a web app here as well. And you know, this classic thing, it's going to sit behind a load balancer of some sort. Um, when you write a new version of this web app, you want to push this out, and there are two ways of doing that. You can the naive way of doing it, which would of course be really bad, is to actually bring these services down and then oops, and then bring them back up again. Now this would obviously be bad because while they're down, the requests coming in here will have nowhere to go. Thank you for popping in, not Matt W, and thank you for the pointers on Redis. Um, Another way of implementing this might be to actually add another instance here of web app, then bring one of these down. Oh, where's Yarita? Delete. And then we could bring up another one. My key shortcut's not working. The little emblazon bug. Um, Excali draw board shortcuts. Stop. All right. Uh, yes. So did I just lose some changes? No, I'm down here. Um, so yeah, you could gradually change these web app instances as you upgrade. There's yet another way of doing it where just say this is the old version of your web app. What you can actually do is you can spin up an entire new service like this, and your DNS is pointing to this one. And then what you can do is you can even be testing this, just making sure that everything's all the health checks are passing. You could have an internal test on each of these functions just to make sure on each of these instances to make sure they're behaving sensibly. And then only once the whole service has come up, at that point you switch your DNS over to this one, and then bring this one down completely. Um, Now, in a microservice application, you can actually do this on. You can do this style, which is much more reliable, but you can do it just on pieces of your system. So this might be my so the Nginx is going to be separate, but I might have my entity services coming up and going down. Um, and then if I've got my session service coming up and going down, it might be bringing up Redis at the same time. Um, so yeah, this is how deploys are typically done in the cloud, and this is called blue-green deploys. The This is the green deploy, the one that's live. You bring up a new one, which is blue, um, and then only once you're satisfied that blue is ready, you make it green, and then delete your old one. That was a tangent. Okay. Sorry, you do get issues in here with anything that's got persistence in it. So, uh, obviously, um, if you've got a database sitting here, um, you need to be very, very careful bringing that one down. Um, so, yeah, just something to be aware of. And Redis is an example of that, where, sorry, not Redis, because I'm not using any persistence in Redis. Uh, Mongo is an example of that. I obviously don't want to be bringing up a new Mongo instance and then bringing down the old one. Otherwise, we'll end up deleting all the entities. I need to be a little bit careful about that. Okay, let's start with a simple FIFO queue. It's not quite what I want, but oh, okay, here's a blocking client. Yeah, okay. I'm going to implement this. It should at least get me started. I am going to implement it in the entity service. So I'm going to make the entity service responsible uh, um, for managing the queue of entities. Uh, so the point of this, I won't be. It'll mean that I can't momentarily. It'll mean that I can't scale the entity service. Um, so over here, because I'm going to make the entity service own this, and I need a way of pushing entities into this queue. If I had multiple copies of the entity service, this would become more complicated, and uh, we'd end up with multiple messages going out again. So I'll need to fix that before this goes live, before I call this task done. But at least if I have a single entity service, I'll end up in a situation where I can have multiple tickers, and they will be able to um, they'll be able to share the work. So that's the goal here. I don't want every ticker controlling the AI on every tick, controlling all of the AI on every. So I need to work out how to do this. It's going to be a little bit tricky here, right? Because the entity service needs to know what kind of queries the ticker needs to do. So that means I'm going to have to move some of the logic from the ticker service into the entity service, at least temporarily. Maybe I can do it a bit smarter and do something like go um, let's do a little sequence diagram here just to think things through. We've got the ticker, we've got the entity service. So what happens at the moment is the ticker service calls into the entity service with a query entities. That's what happens at the moment. That is fine. That at the moment returns, like, for example, all of the entities with the agent component, allowing the ticker to then process that AI. What I'm looking at changing this to at the moment is having the entity create the queues and then having the oh, where's this? Late. So entities will create the queues, and then the ticker service will effectively subscribe to those queues, or it'll pull at the moment. It'll pull components out of the queue from the entity service. Let's just get a little. These. Okay, so on tick, I want the entity service to populate its queues, and then I want the tickers to pull from those queues. Better yet might be to have it do this. Tick, let's move the pull down here, pull down here. The tickers could, at this point, I don't know, configure subscription. I might just go straight ahead and implement it like this, in fact. So this way, the entity service doesn't actually need to know anything about how the ticker service is going to use it. The ticker service would say, hey, I'm going to care about AI agents, I'm going to care about remote commands, and can't remember what else it uses. It's like play sound components, I think, are processed by the ticker service as well. So it would go and say, hey, I need you to have queues for all this stuff. And then the entity service would create those queues. It would ignore multiple requests because remember, we're going to have multiple tickers. So that's pretty straightforward. What I am saying in here, though, is that what we're trying to support is we're going to have one-to-many tickers. And right at the moment, we are only going to have one entity service. Later on, I need to make it so that we can have multiple. All right. Yeah, I'm going to implement this one. That means I'll be starting in the ticker service. X on tick. Oh, sorry, this isn't the ticker service. I really shouldn't have called this ticker over in the transmitter. It predates the ticker service, so it ended up getting that name. All right. This is a pretty big index function, index file. So yeah, here is the main loop. Goes off and processes the AI, processes the sounds, processes the remote commands. What I want to do is I want, as this comes up, I want it to talk out to the entity service and reconfigure the queues. All right, so let's do that, and something like that. I'm going to make this async. Wait, that. Now, over in here, I probably want this uh, to actually return some sort of a context. Because this will presumably return some handles or something into the queues. Um, oh, that's pretty cool. Okay, it's not quite right, but we are going to do, we're going to configure queues. We're going to pass it a some sort of a configuration object. Let's say that it'll pass its own service name. This allows the entity service to dedupe these requests more easily. Yes, we want queues, but we want these to be named. So let's do AI agents. These will need to be configured in some way. Sounds, oh wow, Copilot is awesome. Remote commands. I don't know how I went so long without using Copilot. So next I need to actually pass through a configuration for those. I need to tell it when we're fetching items from the AI agents queue, I need it to know what our query parameters are, basically. So I suspect that if we process AI agents, I'm looking for the all, here it is, here's the query. I suspect if I just pass that in as the configuration of the queue, I will just nest this one deeper. Let's go query is going to be that. Now, I'll be really impressed if Copilot can work out the other configurations. Huh, it did it, I think. Yeah, it absolutely did that. Okay. So whenever we are polling for AI agents, it's going to go and find components that have this agent on them. I should just double check its work on these. Process remote commands is a remote command request. Remote command request. And sounds is a client action. Excellent. Okay. So in here, I could pass through other things. I'm not actually going to pass this through, but I can imagine, a batch size being like 100, like try and pass me 100 agents at once type of thing. Um, because the entity service doesn't have a good idea of what we're going to be doing with the results of this. So in the case of sounds, I could easily process 1,000 of these at once. But in the case of AI agents, maybe I only want to process 10 or 20 at once. The entity service has no way of understanding that. That should be to do with um, the configuration of those queues. Okay. Now, I am going to get this to just return um, by Alt V. That going to return a list of the queues that have been created. No, let's let the entity service do it because maybe the entity service wants to create some handles or something like that, and that's actually what we want to return out to the caller. Okay, now something I didn't show on stream is one of my services. It's probably the transmitter service. I actually did add the concept of a context. We show that. No, it doesn't look like it. Maybe it was the receiver. Oh, session service. Yes, here it is. Oh, I accidentally turned on um my chatbot spammer. Sorry, that will come up periodically, every half hour, every hour. Try to publish a devlog episode every 2 weeks. It's been a while since I've done one of those. So in here, this is my create server function. This is common to all of them. What I needed in here, because I needed the sessions to be able to talk directly to a socket, the implementation of the sessions controller needed to be able to send packets out to a UDP socket. And so this sessions router needed something to be passed into it. So what I've done is I've added this context parameter to my configuration for Express. So when configure gets called, this is just the general server configuration. It initializes UDP socket. It passes back one of these objects, and then that gets passed into the next step of the configuration. Now, likewise, we could pass that into the tick function, or into the tick functions, sorry. And that is precisely what I need down in here because I need the implementation of on tick to know about these queues. Otherwise, it won't be able to subscribe to them. So over in here, I am going to pass a context, interface context, and this just needs queues, which for now I think I'll just make a map of a name string going to a string for now, and I'll assume that's some sort of a handle. This I'm going to make return a promise of context. Still need to implement this. Um, okay, I think that this type in here is probably going to be defined by the entity client. That's okay. I'll get to that and I'll fix all the compile errors after once they come up. So next I want to change the definition of this so that onTick can take a context. So server config takes a tick. OnTick is going to be a context. This is going to cause file errors in all of my code, I think, that has a tick. That's all right. And then when we actually call out the tick, we need this to pass the context. Here's the context here. So I think we can literally just make this no. Um, oh yeah, fair enough. Yep. Tick. And then I can just make this one tick. And this one tick. I'm not a big fan of this. Hold on. Only because I looked at this code recently and I think I actually decided this should be an array. Still make it optional. I presume I can't just set a default for that, can I? In interface. So that will break down here because I need to make this a for each. Server config dot ticks dot we've got tick handle. This is going to need to be tick handles. And then I'm going to map this like that. All right, how's this looking? No, this could come back as undefined. So let's do that. Explicit about the type here. Uh, that. And then we want to clear intervals. Tick handles dot for each clear interval. Nice. Okay, so that was a little bit of a tangent. That will hopefully cause a whole bunch of my other code to go red, and it's just a fairly minor change to correct all of those. But what was I actually doing? I was trying to make it so that the tick handle takes the context. Yep, it is doing that. I'm pretty happy with that. Okay, I find all of the instances of this. Is it Control B? Control. How do I? I want to pin this. How do I pin that? There it is. Purely because I want to run through these and then just change them all. So that is going to be ticks. Be that. Unfortunately, this seems to work. Forgot about bind. Can't remember when, but that would have come in handy. I just wanted to bind a single parameter. All right. I've got that. What's the key combination for next? Alt Shift down. That one does not use ticks. That one does not use ticks. That one doesn't. This one does. It'd be quite nice if Copilot was able to make these kind of changes, but it really only inserts code. Tick is going to become ticks. Now, the whole reason I just made this change, well, yeah, it's not exactly what I want to be working on at the moment. It is this case here, where I suspect I want multiple ticks running because there's multiple kinds of cleanup I need to do here. There's ticks. All just the imports and exports. Excellent. All right, I'm slightly getting where I was at. Oh yes, I've got the context now gets passed through, which means that this on tick should be able to accept context. Cool. So I think I can do this. That probably needs to be a string or something. No, it just shouldn't matter, right? It's the actual complaint is about the fact that doesn't take a parameter. Process sounds context dot cues dot sounds context dot cues remote commands. Yeah, I think I might make these URIs. That would probably be pretty cool. These were URIs, then all these guys have to do is call out. Oh no, I'll make them an ID, and then they'll call out to a queue. Um, so let's do whole queue and pass it. Um, do problem with Copilot is I often find myself just sitting there waiting for it to write the code for me. Not quite sure why it doesn't always write code. Or I'll get used to it. What's this? It's not all. Oh yeah, okay. All right. I just need to implement poll queue and figure queues. We can figure queues first. Oh no, I need this to be a type, not an interface. Because give this a name. Nope, that's not what. It's too quick to accept Copilot suggestion just then. Um, see. Oh, this is wrong anyway. Yeah, it should be service is the service name, and then we've got queues. Let's try that again. Service, a string. Rename this one to figure queues request. Queues is then name goes to a query. Add a string. Come back in here, take a the query. Have I defined that type somewhere? Type does query take? Yes, query parameters. Wow, I've thoroughly messed up the formatting here. Welcome back, Formal Goose Foundation. Currently implementing a pub sub mechanism so that I can have multiple instances of the like the AI type services and have them share the load rather than each of them just processing every single AI agent on every tick. It's a work distribution mechanism I'm developing at the moment. Okay, so what on earth is wrong with my... Oh, I'm missing a brace. That's better. So that's pretty cool. A single page for managing your apps. Config. I'm going to assume you're in America rather than in Australia. It'd be pretty early on a Thursday for, for finishing off Bottle of Rum. The configure queues request. All right. Now, I want this whole thing to also return a configure queues response. Oh, UK based. Wow, yeah, like there. But oh, a bit after. Oh, 1 o'clock. Yeah, okay. But hey, if you don't have work on tomorrow, then I say go for it. Configure queues response. You do have permission, Formal Goose Foundation. Okay, so yeah, I've never really used Azure in anger, but I am quite a fan. It does seem to have ignoring the free plan side of things. Uh, there's a couple of things they do really, really well. One is their APIs are just absolutely awesome. They're clearly written by developers for developers. Like if you take something like AWS, you end up with services like SQS that were clearly written for some internal use case at Amazon, and they just don't support, half of what developers need in a queuing system. Whereas Azure just has a really flexible queuing solution. Uh, yeah, I'm a big fan of Azure. And the other thing, I've got a colleague who he's basically got a permanent free plan on on Azure just because he's working on little tiny side projects. They classify them as startups, but they're happy to just keep on giving him free usage, just to let him just play around. So they're pretty good with that kind of thing. That said, I don't like their configuration console. I find that thing so horrible. All right, so in here, let's go for, yeah, sure, let's just call it an ID. Start client. Um, Close enough. Post. Yeah, that was actually what I do want. Yeah, I wanted to push into /queues. We push in the config and we return await that as that. Brackets perhaps. Oh, oh, dot JSON. What am I doing? Um, Man's fingers. What am I doing here? Yes, I want to await that. Oh, got an extra bracket there. Okay, that's a good start. I presume it's not await. Wait that. There we go. Let's welcome back, random guy. I am going to simplify this code a little bit. Form an expression, really? Close bracket, open bracket. Like an expression to me. Oh yeah, okay. Now we can just await response.json and convert it to response type. Much prettier. Okay, so that is what we're going to do for configure queues. This obviously needs to be a promise. And so on to the second function, which was what called poll. Poll queue. QID is a string. All right, let's just get it to do pretty much the same thing. Oh, well, hang on, can Copilot help me here? Copilot not doing anything? Surely you can write this code for me. All right, I'm actually just going to install this update. I don't like writing code anymore now that I've got Copilot. And files and Copilot, yeah, you can update them both. Start. Okay, Copilot is live, and it is, there we go, that's better. See, that's exactly what I want it to do. Except that's meant to be a post. Post into that. Now this is going to return a promise of entities. That's actually not needed. A bit confused how it got the typing of this stuff right, but I'm gonna ignore that. Yeah, sorry about the spam. I clicked the wrong button when I started the stream. At some point I set up those notifications, and yeah, all those if you don't mind. Response. Let's return response. Just getting rid of these warnings. We don't ever use those responses, but at least it keeps IntelliJ happy and means that if we do ever use them, we won't have a bug. Okay, so I need to implement these two endpoints now. To keep things simple, I'm going to put these into /entities/queues. I think, do I need that? No, this already has those prefixes on it. So time to go to the entity service here. Need to configure the routes. Oh, this is getting pretty big, isn't it? Entities router dot route queues. This is actually, yeah, I'm posting into this ID directly doesn't really make sense. I am going to put a poll in there. Likewise, poll. This is really bad. This isn't great style. You're not really meant to post into verbs as a general REST style thing. Having verbs in your URIs suggests that you're using REST wrong, but yeah, whatever. I mean, I could make this poll request or something like that. You know, then we're creating post as a create, so creating a poll request. But I know what I'm doing. Well, I know what I mean is what I'm trying to say. Okay, enough rambling excuses for my poor coding style. Um, configure queues. Is that rotation? Wow. I want configure queues. It's going to do that. Hopefully it'll write the function for me. Not quite what I want. Close. So pull the queues out of the body. No, this isn't even close to what I want. Okay, I'm going to need request dot body, and we are passing through in here. I need the service name and the queues. So I'll just do const service, that's service name, and queues equals request.body. Okay, so we've now pulled out those two things. No, I don't want to call into the entities controller. Copilot is obviously confused a little bit about how these modules relate to each other. So what I'm going to do is I'm actually going to store the queue configurations in Redis. Sorry, not in Redis, in Mongo. I mean, I could store them in Redis. I don't really need persistence here. That said, I don't have a Redis instance next to the entity service. What's the path of least resistance is probably to just put Redis in here because I don't want to have to do tables and things to manage this stuff. I'd rather just push this data into Redis and on each tick, pull it back out again. Yep. So, this is what I love about Docker. I just need to find my entity. Well, let's put it under entity persist and let's put entity cache. And Copilot wrote it for me. Beautiful. Back in my config, let's do Redis. Perfect. Now, the one problem I have with Copilot is I am 99% sure it just wrote the right code, but need to make extra sure. Now, who uses Redis? I guess Session Store uses Redis. No, I wanted a URL. All right. Was wrong. That's right. Out of interest, uh, so oh, okay, it's actually learnt. Huh. It's even refusing to do that other implementation now. It's almost as if it worked it out. Anyway, okay, I'm getting this code is getting duplicated everywhere. Does this have any code in it that is particular to the session service. We've got initialize it. This is all just error handling. Be sure there's a better way of doing this, but it's fine. Right. This code is going to move. Is it going to move to? Somewhere up in common. Welcome back, Metalstorm. Currently implementing my pub sub mechanism to allow work to be distributed across multiple instances. So at the moment, the ticker service is processing, for example, when it does AI, it does every AI agent. So if I have 2 instances of the ticker service, all the AIs get processed twice, whereas I want each one to process half the AIs. That doesn't look right. Oh no. Base service, Redis. Okay, I'm going to put a whatever. Let's put it up in here. I'm starting out with a really simple implementation just to hopefully get myself off the ground, and then I can worry about more performant solutions or better guarantees later. Okay, so that export stuff. All right. What have we got? How to do this? Let's just copy some code out of sessions controller. It's going to be something like this. Oh, that's actually pretty good. What I was going to do, but that's better than what I was going to do. Thank you again, Copilot. Yeah, that's precisely what we want to do. So this is intentionally overwriting anything that's in here. Uh, there is potential for some weirdness in here. If for some reason 2 instances of the, let me just find my ticker service. Yes, so the ticker service configures its queues like this. If for some reason 2 ticker services were to have different configurations in here, maybe they were in the middle of upgrading or something like that, So they were running different versions of the software. The last one to boot up will actually change the configuration of the first one. It is, of course, possible to work around this. I could detect that situation, and over in this code, over on the entity service, I could actually go and create a new ID somewhere in here and pass that back to the client. And that way they could each be using a slightly different implementation. That would make my entity implementation really complicated though. My entity service implementation, because it's going to have to work out when it can shut down queues. Now, as it is, the queues are going to be long-lived. I don't have the concept of unsubscribing, but I can always, at this point, I can always just shut down the database, bring down the stack, and it'll delete all the databases, which includes the configuration here. Okay. I need to then return a useful queue name to the client. So we're going to do res.status. Let's just do OK. Has HTTP status codes been... Ah, there we go. Yeah. Status codes. Let's try this again. Status codes dot OK dot send. Dot JSON, sorry. Now, I need to work out what I'm going to return to it. That is determined by the ticker service, really. No, the entity client. Entity client is just going to return a queue name to an ID. All right, well, this is particularly boring in this case. We are going to take the queues object.keys queues, and we're going to reduce them. Let's pull all of this out into a variable response. Make that new name. All right, I think that's right. Ish. JSON response. So all this is doing is it's returning an object that just has each of the queue names we requested and sets the ID to the queue name. I could do more complicated things in here, but this will do me for now. Now, when we poll one of these things, it's really easy to get from one of these IDs to its configuration, because that's just stored in this object here, and that includes the query for it. Okay. Now, the entity service is going to need a tick, because it needs to populate these queues on every tick. implement that. Okay. So on every tick, it's going to populate the queues. Have I mentioned how much I'm loving Copilot? Oh, it's not what I want. So I want to fetch the configuration for any keys starting with, what was it, queues? Well, actually, let's start by moving some code in here. Yep, that's exactly what I want. Like, I swear it can read my mind. But this time it's got it wrong. I need to grab this. Oh no, I just wanted to grab this, and I'm not going to return anything in this case. There we go. So yes, this needs a service name. It needs a queue configuration. So a queue's configuration, not exporting it. That's what I want. Except I actually want to fetch those. Uh, how do I do that? Let us fetch all keys and values with prefix. Fields and values stored at a key. You can't specify a mask. I'm just going to use the dodgy implementation here, is to get the keys and then do this. I think that's right. Wow, this is incredible. Okay, so yeah, we grab the service name. We then get the queues. No, I don't want to return this. I just want to return use directly, I think. And I don't care about the service name. Now, I think that that is now a list of configurations, is it? It's not going to know, of course. JSON.parse that as queues configuration. I believe that's correct. Oops, that's meant to be a bracket there. No. All right, I think this is going to become a reduce. Dot reduce. Just ask Copilot to rewrite this bit of code. Not quite. Um, I'm going to pass out a single queues configuration. So there's the configuration for all of our queues that have been configured for all of the services. We don't care about the service name. Emulator, comma, so close. Here's a string. Oh, I'm not sure that's true. That looks better. Oh, isn't quite right. We do that. This has to be async. So close. There we go. Oh, conversion to type string. That needs to be a JSON parse. Definitely want that to be a queues configuration. Is that necessary? Yes. Something's still not quite right. Oh, because I can't pass an async into reduce. That's annoying. Yes. Apologies for the chatbot spam again. That's bad configuration on my part. Okay. So, good news. The stream has gone fine today. Like I've been disconnected. I was meaning to stream with Streamlabs today, but I messed up my configuration on Streamlabs account side, and I need to contact support to get it fixed. Unfortunately, they were very quick to get back to me, but there wasn't going to be time to sort it out for the stream. Okay, so I need to go from keys to um, configurations. I need to go from keys to the actual configurations. I think that's right. So we get that value, we parse that configuration. Problem is that configuration could be null. So um, okay, if config is defined, otherwise we're going to return null. So now what I think we have is a list of queue configurations or null. Be explicit about that. Queue configurations or null. Nice. Now, much simpler. This doesn't need to be async anymore. This can be a configuration. Don't need to do any that, although we do need to say if not configuration, then return the accumulator. So that just means we ignore it. If something doesn't, if we find a key and the key no longer exists, then we just don't do anything with that configuration. It means it's been deleted or something. I don't know. This should never happen, but we are supporting it anyway. Then do that. This should be a queue configuration or null. I can do better than that. I can make that undefined. I think I can put a question mark there. No. Yep. I don't know. I don't want to have to read that error message. Oh, it to be queues configuration. There we go. Much better. Excellent. So, took me longer to write than I expected it to. We go through, we read all of our configurations. At the moment, there'll only be one configuration. So for that one configuration, we pull it out and we parse it as a queues configuration. So that should now have 3 queues defined in it. We then come through here, starting with an empty set. We just place those 3 queues into this result, and then we return it. Okay, that was a lot of work for what was effectively a flatten operation. Okay, so I've got configure queues and like queues. Let's just come back to here. Here, I think here we can replace that one with just queues. Ah, um, yeah, I'll put a different name on this one. It needs the service name and the queues. So that's going to be service name. Nice. Okay. So next I need poll queue. Oh, I haven't finished implementing populate queues yet. That's exported. Export. Const poll queues. Wait, button queues. All right. Now for the guts of this, what it needs to do is for each queue, it needs to go and execute a query. Okay. Best way to do this, query, don't want the one in the queries controller. Oh, we just import that. All right. Uh, um, roller. Find. Ugh, bit ugly. Not sure why I implemented it like that, but I'm not that right now. All right. Use dot map for a given queue. Nice. Okay, I'm going to make a slight change up here. Rather than queues, I'm going to call this one config. Queue config. What I need to do next, this isn't perfect. If I take a copy of the entities at this point, uh, then we potentially introduce race conditions. Do I care for now? Not so much. I think I'm going to sort that out if and when it comes up. Okay, so we need to put this into Redis. Let's grab the Redis client from here. Redis client is that. It's trying to use the pub/sub mechanism in Redis client. Um, I mean, I'm tempted to try going all the way with this. Yeah, let's do it. Entities dot for each. All right. So what this is doing um, is it's actually grabbing a copy of the entity. So on each tick, we grab each entity that we believe is being subscribed to, and we publish a message. This isn't meant to be poll queues. This is meant to be populate queues. Right. This is part of the timing code. On tick, flatten queues. Nope, we want populate queues. There we go. So every tick, it populates the queues. Um, um, okay, so we flatten those queues. That gives us an object containing the name of each queue and their configuration. So this is actually going to have to be entries. And then in here, we're going to pull out the queue name. And I might as well just do that as a queue. Okay, we'll make this one a map. Make this one a map. This is a promise. Yeah, I'm going to assume that's promise-like. Then do promise dot all of those. Turn that. Promise dot all of those. All right. So for each queue, we publish into a queue of that name every single entity that is returned by a query for that queue's configuration. Perfect. This should be a queue ID. Um, it's a listener, does it? I might need to look up the instructions here. Publish and subscribe. Um, Redis pub sub. Oh, okay. Yes. So perhaps I don't really want the actual pub sub stuff here. Um, and the reason is I kind of want to make sure I'm blocking. Well, surely I can block in here. Um, all right. So an example of it in Ruby. Um, Ruby is rusty channel. C. I don't know what that is. Oh, is it just a private or something? Yeah, okay. I might just have to try this. My other option here is to do this using like WebSockets or something like that. So the issue I've got is when I don't want the client to have to call this poll method because the model used by Redis is to subscribe to a message, which then causes a callback to get called. So I really want the clients, which in this case is the ticker service, to hold a connection up and have data passed across the wire as it becomes available. Now, WebSockets feels like a sensible way of managing that. I can't remember the name of the protocol that normally sits over WebSockets, but I'll be able to find that in a moment. So basically, these messages would then get sent through to the tickers. All right, let's find an example of WebSockets in Express. I think this is a good solution. I think this will actually reduce latency quite a bit. Okay. I need the WS npm module on both sides of the connection. Terminal, there we go. So we need the entity service, done, add WS, and we need the ticker service to also have that. This isn't quite what I want. I want it to upgrade an HTTP connection. Oh, here we go. There's the upgrade. All right. Or how I get the client to tell Redis message has been handled. Oh, I presume I do it just by returning from the callback. That's going to be a problem, but okay. This is going to get a bit ugly. Okay, so I'm not going to poll in here anymore. I'm actually going to have a WebSocket that will subscribe to a queue. back in the control, no, not the controller, I want the REST client. Now, this is where I probably really regret naming my packet receiver RX because I've got a feeling I don't want this to be promise anymore. I mean, one pattern is to use a callback in here. The other is to return a stream of entities. Might be a good way to do that. RxJS. I've not used RxJS before. I've used reactive Java, which is based on this. Now, I'll start out just using a callback. Now, I'm going to leave it in for now, this configure queues, but I kind of note that we could potentially also pass the individual queue configuration in our subscription request. Again, we'd get weirdness if the configurations diverged. Let's make that a subscription. Entities router. Okay. Now, this I am ultimately going to need to do handle the upgrade request response, I presume, and open a WebSocket. Call the callback. Okay. Be nice if I could get Copilot to write that for me. What's this? Update dependencies. Yeah. Very confused. All right. I think I'm going to have to finish up my stream soon. I'm getting pretty hungry here. But let's just take a look at this. Oh, no, not that one. I want the WebSockets. So over on the server side, I need to do something like this. See if I can find some other examples that are a bit closer to what I want. All boring. Create a WebSocket server. So they spin up Express. They listen on port 5001. And then I presume this is configure the WebSocket on that server. Okay. 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 Let's just try implementing this. I think that this is all just going to go away. In my index, REST clients, I want entity index. When we configure Express, try that again. I just want to take this out as a common method. That's better. Okay. So in here, we're setting up the entities route. I need to create a WebSocket server as well. Nope, there it is. No server is true, and path I think I want this to be the well, I'll just set it to WS for now. But I need to somehow work out how to connect the requests into the individual queues to this WebSocket server. Server does not exist. What? Something gone wrong. Terminal? Something like this. Do I need the types? WS? Yeah. That is okay. That's looking much better. All right. We do that. I then need to do. We'll put it in there. Otherwise, it's not going to get routed properly by Nginx. And then I want to do the app on upgrade. Presumably, this is where we can get the actual request that we can map. We can get all the information we need to perform the subscription. All right. Yeah, we need to do that. It connection rate. Sockets. Connections fallback we've added as the fourth argument. This so this is where the actual subscription should happen. So I suspect we want in here subscribe queue. I'm just going to do that. I very much doubt what I'm doing is correct here, but just see. Subscribe Q take. Well, in here, I'm going to have a callback. Like so. Okay. So I think this looks kind of right. Can't have a wait here. Do that. Yes, good. Whenever an upgrade event happens, we ask the WebSocket server to handle that upgrade. Oh, this isn't right in here. Oh, this is right. Yeah, so when the new WebSocket is created, this callback will be called. And then I create a subscription to the queue. And anytime an entity comes in across that subscription, we send it out over the WebSocket. Nice if it were that simple. I mean, obviously this code doesn't live in here, but parameter request implicitly has an any type. This is meant to be HTTP request, express.request. Doesn't like. That. App dot on uh, sign up. Oh, this is just medium. Yeah, okay. Let's be my cookies or something. There we go. Grabbing WS, they're grabbing Express. Awesome. Uh, oh, okay, this is interesting. Seem to handle the upgrade in here. They are able to start our own server. Let's add some code to enable broadcasting. It's almost what we want. Okay, so this is just going to take each packet coming from the clients and broadcast it out to all of the clients. When they see a message come in, I still don't see where they handle the upgrade. They don't. So let's look at what they do anyway. When when a message comes in from a client, they log it, great. And if it starts with broadcast colon, then sends that. That's fine. I think that that's just ws.send will work just fine there. Not a broadcast, then we do that. Okay. But I want an upgrade example. Really want grade. Really want TypeScript. R. All right, this looks like what I want. Rather than calling into WS directly. Ah, perfect. All right, let's undo this change. I don't want that. Package.json, I'll get rid of WS. And WS. And then again for the ticker service. Get rid of. Oh, did I not put S in there? Apparently not. Bit confusing. Oh, because I just did a D, not a CD. Yeah, okay. I have no idea what that D command did, but this is all fine. So, in Express for the entity service, entities route, I believe that I can actually just say .ws here. No. Oh yeah, I need uh, not. Uh, app going to be Express, and we are going to return an Express router. The what have we done? Yep. Colon. Yeah, okay. Okay. Do that. And we, all the way down here, we return entities router. I'm not going to have default export on this anymore. All right. Now what we can do is try putting that line in. A bit better. I don't think I need to do this. I really have to finish up soon because I'm clearly not firing on all cylinders. Stupid spammers. Get rid of the spam. The spam, and YouTube seemed to have detected it. OBS. There we go. All right, so back in the text, this is where I actually want that code to live. Part of this, we do that. Then Oh, okay. This is just, yeah, this is nasty code. Let's do port express WS from express WS. We will install that. Oh, it's meant to be types. Right. Types slash express WS. Hopefully that finds it. Yes, it did. Excellent. That should get rid of that error. Now we come back to the index. Got that. Do express WS app. So that enables WS. I understand it. I've just done the equivalent of that. So make sure to set that up before loading or defining your routers. Excellent. So now I should be able to define a route. Entities router. But it looks like it has not updated the prototype for the router, which is a bit annoying. I can cheat here, right? Let's go export const. That's what I was trying to write before. Create entities router. This takes app. Turns an express router. Fine. Then I think I have to do. Still not right. Ah, okay. I'm going to just comment out this create function because I'm not sure what this is meant to look like yet. I've got a feeling I can indeed go entities router, and while IntelliJ is going to complain, I've got a feeling this is going to work because at runtime, I think it will. That should be out. I think this will just magically work. I don't really like this. Um, I mean, alternatively, can I in here do app.ws? No, I can't. Um, So I'm probably going to have to do some sort of magic to convince IntelliJ that this code's okay, because I really don't want errors showing up in here. What's the best way of doing that? Oh, that's meant to be ampersand. This and an I route. All right, I think that is all I need to convince it. Uh, like WS router. I'll put in a hack here. Oh, damn it. Oh, I think I just undo. Bad job of. Oh, I just deleted all my restream bot. I unhide. Message. There we go. Okay. So in here, I just need to make this as a WS route. Yeah, it's hacky, but hey, why doesn't that work? Oh, because does work. All right. Let's just move that hack and line down. And okay. Slightly annoying having to hack around this stuff so much. That down here. Why do I like this? Oh, okay. That is meant to be an iRoute. iRouter. Still not. Got it. All right. This is all just a hack because IntelliJ doesn't know that the prototype has been changed here. I wish I didn't have to do this, but I can't. It's detrimental to have errors, false errors being reported. I don't believe that this actually changes anything. This is just keeping TypeScript happy and saying, yeah, I promise this has a .ws method on it. If it doesn't, then obviously this will get an error. All right. I'm not sure what's changed here. Ah, should be coming from like common or something. Base service. There we go. What have we got here? Context needs queues, which is a name to. This is going to be a queues configuration or something, isn't it? Uh, oh, yes. Okay. So this can be, I don't know, const. Queues response. Turn queues is going to be equals that, and then I'm going to return. It's going to be able to just do it for me. Please do it for me. Nice. All right. Now this code is all about to change lots, because we will no longer be awaiting on entities. What we will be doing is entity client dot I mean, this method will no longer need to be called in a loop, right? This will be a permanent, a promise that never returns. So entity client dot subscribe queue, and then in here, all I need to do is process single AI agent. I'll await that for good measure, but then in here, what we actually want to do, now notice I can't return in the timing information per tick anymore because the ticker service, uh, very, very, very inappropriately named ticker service now, will not have the concept of a tick in it anymore. So, described that, and then I'm just going to return a promise.never or something. AS create promise that never comes. Promise like that. All right. Likewise, process sounds will do a describe queue, take a queue, take that. Wow. Let's send a. I don't think this is what I want. No, I want it to do what's inside here. So, go. Grab this code. Bracket. All right. That. Uh, So in here, I do need a const now equal to that dot value. Go. Let it write the code. Don't know how many we're getting on a tick. That's okay. Don't need that for. I can then do something like that and return promise. I'm sure I can come up with a better pattern than these empty promises. My indentation. Oh, nothing. Oh, patch. Whatever. Okay. The main ticker service then needs to change because I believe these are currently being called in a loop. Is not what we want. I did that work to expose the context to the queues and never actually, and I don't need it anymore because I'm not going to have a ticker. Well, I'm not going to have a tick function, ticker service. Okay, so in here, I'm then going to say context.queues. No, it's going to be a promise.all. I don't like this. I need to make sure that this this function can return to allow the health check to come up. So what I'll do is process single AI agent context.queues dot on tick function. There's my on tick. I just want to do these three. On tick can go away. Do those and just put an empty callback on these. Turn context, even though we don't need it. That will allow the server to come up, but we'll leave these processes running, subscribed to their respective queues. Okay, where am I at? So the ticker service, I believe, is now fully ported across to use the fallback mechanism. I will need to change the subscribe function. This actually needs to handle the upgrade, I suppose. Can't remember what I called that. Entity route. Yep, that is called subscription. Yeah, I expect to have to do something in here um, that will call the callback. Time to look at the documentation. I really hope I can get the request parameters out of this. Otherwise, I've just made a very big mistake. Oh, hold on, yeah. So I assume. All right, let's try this. Subscribe queue. Not what I want. Something like that. I want something like that. I don't think I need to specify those. If I instead say that this is a function that. Oh, that's so WS function that takes a callback and returns yeah, any. void. Okay. I think that could be async. That can be await. Okay. So what this should be doing is it should be setting up an endpoint on there. When somebody does a WebSocket request to it, we will subscribe to the queue using that ID. And anytime a message comes back, we will send it to the client. Now, I've still got an open question here, which is how do I mark the message as processed? And I assume the answer is I don't. Which is not ideal because this is just going to start spitting presumably entities at the client as fast as it can. Well, we'll see. I don't want to have to do a handshake in this on top of WebSockets. I'm hoping that there is already a handshake of some sort implemented on this protocol. In which case, when this gets through to the other end, which is going to be in the ticker service, it will call this process single AI agent, and hopefully it will await on this. That is my hope. All right. So I think that is the entity services subscription endpoint done. Maybe this is all of it done. Oh, this doesn't look right. Yes, here we go. So this is the last piece of glue, I think. So when we subscribe, we're just going to call the callback. No, that's not allowed. Grab the message, we parse it, and pass it to the callback. I think that callback is async, in which case we definitely await on it here. That cannot name. Let's just do sync sane. Whatever. Just see what happens. I'll spin it up and then put out all the fires. It seems to be starting things. Looking healthy-ish. Some stuff hasn't come up. Stuff will time out in a moment, so let's just shut this down. What did I do? So TX and API failed to come up. Let's grab a shell. Bring down Docker. Bring it all up again to see what happens. Entity service did not come up properly. WS is not a function. All right. What I'm going to try is something like that. App.route queues. That. Oh. Okay, what other options can I pass to this? Oh, they take a server. No, that. Express.us app. That. 30 default export. Okay, this is actually expected. Get rid of that. Bigger router. Here, I'm just going to call configure entities router. Like that. Line 155. All right, this is looking a bit better. Implicitly has any type. Okay. Return something. It does. Okay, so that's what I'm meant to be doing. I'm meant to be saying something like WS app equals that, and then I can do WS app. That should be app.that. Then WS app.route. No. I'll just do it like this. So in their example, find it. There it is. Do that. I've just got this function like that. whose declared type is neither void nor any must return a value. Line 130. It's in a second. Oh, yeah. Go. Oh, right. That appears to have just spun up. Let's have a look. Yes, entity server started on TCP 8080. So that's up. Ticker, I suspect, is not properly up. A bit surprised that the health checks aren't working on that. Yeah, this is very straightforward. This is in the entities client. And I just need to get rid of that slash. I imagine our queue is going insane at the moment. This entity cache, can I get any statistics on this? I probably can't easily. It's not begin with a slash. Configure queues, there it is. I think this looks like it's up, doesn't it? It's not, almost. Ticker index. Queues.ai agents. Oh, okay, so this is just something silly. Line 145. Log this quickly. I keep saying I'm going to finish up streaming soon, and I really do mean it now. I'm that close to getting this thing passing messages around. So yeah, this is ticker, debug. So yeah, as we come up, we've got context, use is undefined. Reconfigure queues is the thing that's not working. All right, step through this until I can work out where the missing data is. So response is literally just a map like that. All right. So we're getting these back. what the syntax, what this type is. Is it smart enough to know? No, it's not. So I think I need to tell it. Oh, there we go. That's a configure queue response. Yeah, so I just need something to map between these. And it's not the job of the REST endpoint to do that. Oh, oh, sorry, I thought that was REST. Yes, so this is going to get a context. We've got our response. I need to do some sort of a reduce on this. So yeah, we're going to return queues. For each one, I just need to map its name to uh, I need to map its name to its ID. I mean, they're the same value, but might as well do this properly. We need entries on the response. It's not response.queues. I'm not sure why So wants to say that. Copilot is definitely wrong there. So with each of these entries, we're going to reduce them like that. That is the value.id. Right. All right, I think that's okay. Reducers look like they're a lot easier to write with Copilot. All right, let's see if we can get this to run now. Looks much better. See the names of the queues coming through. And then it is failing while trying to what? Index line 4. Trying to subscribe to the queue. I. Oh, because I've not told it to do. If I go to subscribe queue, this is doing a post. All right. So this is where I'm going to finish up the stream today. I will be streaming again tomorrow, same time. I may off stream just have a bit of a shot at writing this method. This needs to establish a WebSocket. As soon as I can get it out, sorry, Fishtiver. Just had so much on the last couple of months. Hopefully, I get some time to work on it next week. I won't be doing devlog next week. Sorry, I won't be doing streaming next week. So hopefully, I'll find a bit of time to sort out the devlog. Um, yeah, so maybe this afternoon I will try and get this method implemented. So it just needs to connect through to. We're not meant to post. We're meant to just establish a WebSocket directly to this. I think. Oh, your streams aren't coming up in your sub box. That's a pain. You're aware that it's a different. Can't remember what it's called. Um, a different channel. It's the streams channel, not the games channel. Um, I presume you are aware of that. Yeah, YouTube can be a bit of a pain though. So yeah, I'll try and get this implemented, and otherwise I'll catch everyone around tomorrow.